Modulation and multiplexing. Modulation and multiplexing are electronic techniques for transmitting information effectively from one place to another place. You want to transmit the data from one place to another place, and for that, these are the effective methods or techniques to transmit the information from one place to another place. Modulation makes the information signal more compatible with the medium, whatever the medium we are using. It may be wired or wireless. It may be wired or wireless. Whatever the medium we are choosing, uh, with respect to that, whatever the modulation we are choosing to transmit through these type of medium, and it will always transfer the information with the proper way, and at the receiver end also it won't be having much of the difference with the information. Whatever the information they want to send, that will be available at the destination also. And multiplexing allows more than one signal to be transmitted concurrently over a single medium. Over a single medium only, you will be uh, allowing. See, multiplexing means what, you can take it as, you have signal 1 2 3 4 5, 1 2 3 4 and 5. 5 signals are there. You have a single line of transmission, that you can take it as single wire. This is an wire. Okay, wire or channel, anything you can take. But to reduce the time for the transmission, uh, at the destination they are waiting for all the 5 signals. At that time you will be multiplexing all the signals using the mux. Okay, using the mux you will be multiplexing it and transmitting through the single wire. Then no need to implement 5 wires separately for each and every signal. Okay, if the at the destination end, it is transmitter end and destination end. If they want signal 1, they will be connecting with signal 1 line. 2 3 4 5, 5 lines has to be maintained here. But if we are going for the multiplexed part, at the receiver end you will be having demux. Okay, and if you want a signal 1, you will be here, if we are selecting the line 1, it will transmit this signal, and at the receiver end also you have to select one line. Then select the line 2, 2, select the line 3, 3. In this way you will be transmitting the data by using the multiplexing application. You can see modulating and multiplexing in one block diagram. Multiplexing, as I told you, multiple baseband intelligence signals will be there. Here they have shown one n number of signals. Multiplexer will be multiplexing them, means you have to select any one of the signal and you will be transmitting composite or multiplexed signal to the modulator. Modulator will be, modulation function will need always a carrier signal. For modulation is, in detail you are going to learn in the next modules and all related to this modulation. How many types of modulations are there, which one will help with respect to the transmission of signals, everything you will learn in using the modulation part. Modulation plus your carrier signal will give you, sorry, this one, not modulation. Your original signal plus carrier signal, you will get modulation output. That is a representation of your modulation. Original signal plus carrier signal, you will be getting modulation. You will be doing some process by using these two signals and you will get the modulation output. Okay, that's why to provide that carrier signal, to get that carrier signal, you need to use oscillators. Okay, it will be always a constant frequency. constant frequency. And you will be having RF power amplifier as the transmission will be through the medium. It needs to have amplified signal transmission because in between, if the longer distance transmission is going on, then it may have a problem related to power consumption through the transmission lines. Everything will be there. That's why amplification is the best method to maintain the proper signal strength. Okay, and you will be transmitting through the antenna if it is a wireless transmission. Next, we are going to learn about signal. That is, a signal is a pattern of variation that carry information. It is a pattern of variation that carry the information. If it is a voice signal, you will be having this type of signal, and you will be, if it is a sine wave and cos wave, it will be in this format. And if you are transmitting digital signal, zeros and ones will be there. And signal are represented mathematically as a function of one or more independent variable. Means you will be having independent variables will be there. One or more independent variable will be there, like with respect to time and voltage. And electrical signals like voltage, current, and electromagnetic field in the circuit, all these things come under independent variables which represents the signals. Okay, acoustic signals like audio or speech signals, analog or digital, you can consider any of those. Video signals like intensity variation in an image, and biological signal like sequence of bases in generation, and gene, and noise, which will be treated as unwanted signal. Okay, these are the different type of signals which we can see, which are available in the earth. Signal classification, you can see we can do 7 different type of signal classifications. One is continuous time and discrete time. That you can, continuous time is a, always you will be having continuity with one signal value to the another signal value. It doesn't have any discrete values, means continuously without lifting my hand, if I am writing the any signal, that is continuous. Discrete means you will be having the discrete signals like this. I have to lift the my hand. If it is showing as a high value, that can be taken as 1, empty value is 0, 1, 0, 1, 1, 1, 0, 1. In this way, you can write the digital signals. Next is energy and power. Energy and power is both are one type of signal, and real and complex signals. Real signals will doesn't have I value. Your complex signal will be having the I value, that is root minus 1 is a value of your I, non-real value. Next we have periodic and non-periodic. Periodic means continuity will be there. If I am writing the signal in this way, this is periodic, means repetition. Actually, I can take it as a repetition. If it is not a non-periodic, it is not a periodic, then you will be having this way, or frequency is changing, that will be non-periodic. Analog and digital, you will be having continuous and discrete time. Analog and digital, you will be having continuous signal, and digital is zeros and ones. And even and odd signal, domestic and random, deterministic and random signal. These are the different type of signals we can study in this communication system.